This week we're going to move on from thinking about how fast things move and how far they move to the forces that are involved in causing them to move. Okay, so we're going to be talking about balanced and unbalanced forces and how these relate to the movement of objects. So we'll start with a simple example. Let's imagine that you are stood on the ground like this. Okay, now there is obviously a force which is pulling you down into the ground. Okay, and I'm going to draw it over here, but remember, so the force is going down here, but I'm just going to do it here so it's easier for you to see. Okay, all right, and that force is known as your weight. Okay, and that is caused by gravity. Okay, so due to gravity. Now, if that was the only force that was happening, then you would fall down through the floor. But that's not happening at the moment, is it? All right, so that can't be the only force that's involved in this situation. So there is another force that's involved, and it is going in the opposite direction, straight back up through you, okay? And it looks like that. All right, and we call this force the reaction force. Okay, now, where you are currently, okay, you might not be stood up, maybe sat down, you have your weight, and then there is the reaction force, which is in the opposite direction. Now, you need to ask yourself a question. Am I moving? Am I moving up? Am I moving down? And the answer is no. You're not moving down through the ground, and you're not moving up to float in the air, which means that these forces are equal and opposite. They are equal to each other, so they're the same size, and they're in the opposite direction. So we say that they are balanced forces. Okay. Now, if forces are balanced, what that means is that they cancel each other out. All right, and because they cancel each other out, there is no change in the current situation. That is really important. I've been very careful about how I've said that. Okay, you might be thinking to yourself, okay, well, if the forces are balanced, it means there's no change in position. So your weight is equal and opposite to the reaction in the ground, and because of that, you do not move. Now that's right, but it's not exactly true to say it like that, and we can do another example to see why that is. So let's imagine now that you are in your car, if you've got a car. You might not have bought one yet. Here you are. Okay, so what's happening in this car? Well, the engine is driving forward. Okay, so we have this driving force. But there are also some other forces here. Okay, so here on the wheels, we have friction. And we also have drag or air resistance. All right. Now, let's say that you are going 10 miles per hour. All right. And let's say that the driving force is equal and opposite to the friction and the drag. All right. So here we have balanced forces. But you're not stationary. You're not still. You're moving forward at 10 miles per hour. Okay. So what does it mean in this situation? Okay, well in this situation it means you do not get any faster or slower. Okay, so it means the speed does not change. Okay, because all the forces are balanced, you stay going 10 miles per hour. All right, so you can think about yourself up here. Because all the forces are balanced, you stay still. And here, because all the forces are balanced, you stay at 10 miles per hour. Okay? So let's suppose now that we have me in my car. All right, so this is me in my car. All right, and I'm going along, and it says here I'm going 40 miles per hour. Okay, so I've got my friction from the contact between the wheel and the road. That's my friction. And I've got some drag or air resistance from the air. But I've put my foot all the way down on the accelerator, and what that means is I've got this really big driving force. Really big driving force. Okay, and we can say here that the driving force is greater than the friction plus the drag. All right, so now we're in a situation where we have unbalanced forces. Okay, so these forces, they're not equal to each other now. So the question is, what's going to happen? Well, when the forces were balanced down here, you stay going 10 miles per hour. Whereas now, because this forward driving force is much bigger than the friction and the drag, it means that my speed will increase. Speed increases. Okay, so let's do another one. But this time, we're going to do it slightly differently. Okay, so I'm now going to, instead of drawing out a picture of a car each time, all right, I'm going to draw something called a free body diagram. Okay, and in fact, what I'll do is I'll draw this picture out as a free body diagram. So instead of my car, I'm going to draw a box. Okay, and I've got this big driving force. Okay, and then going in the opposite direction, I've got these really small forces. One of them is friction and one of them is drag. Okay, so you can see that this picture here has all the same information as this picture, but instead of drawing out the car, I'm just drawing it as a box. All right? Now, let's suppose that I decide I'm going too fast and I want to put the brakes on. Okay, now putting the brakes on is going to increase the amount of friction. So I'm going to get rid of that force, and I'm going to replace it with a much bigger friction force. All right, so this is my much bigger friction force. All right, so now we can see that the friction plus the drag is bigger than the driving force. All right, or we can say down here, we could say driving force is less than friction plus drag. So, because I have unbalanced forces, that means that I will start to slow down. So speed will decrease. Okay, good. Now, there is one thing missing from my free body diagram, all right? And that is, well, my car isn't moving up or down. So there are some other forces that I should put on here, and they are my weight due to gravity and the reaction force. Okay, so the car going along has got all these different forces acting on it. The driving force pushing it forward, friction and the drag slowing it down, the weight caused by gravity, and the reaction making sure that it doesn't fall down into the ground because of gravity. Okay, and that's a free body diagram.